Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to demonstrate how to add vectors when they're in unit vector form. So this will be a pretty short video. So imagine we've got the two vectors here that I've listed. Vector A is 15i plus 3 in the minus j. That I should have a caret symbol over it. And then we've got a second vector B here, which is minus 10i minus 7j. Now the first thing you might wonder is, why is this one expressed like minus 10i minus 7j? And here I've got plus 3 in the minus j. Well, I just did that just to demonstrate you can write these either way. Like, for example, vector A here, if I wanted to, I could write this 15i minus 3j. These are equivalent, and I did that just deliberately to make a point of the equivalent way that you could write these. So first of all, to do our vector addition, I'm going to go ahead and sketch these vectors. So this guy right here, 15i minus 3j, means 15 to the right and 3 down. So on this scale here, I may do something like this. So let's say maybe here to here is 15, 3 down might be something like this. Now I just am completely sketching this. I didn't mark it out or anything like that. So there's my first vector, vector A. And again, the intention there's 15 to the right and 3 down. The second vector, vector B, is 10 to the left and 7 down. Now, when you do a vector diagram, you should always draw these so that they're tip to tail. So what I'm going to do is I'm going to draw this minus 10i minus 7j starting here so that the tip of vector A is touching the tail of vector B. So this is saying 10 to the left, 7 down. So that might look something like this. There's my vector B. 10 to the left, 7 down. And again, I don't have coordinates on the page. I'm not worrying about that. This is just a sketch here. The resultant vector starts here and ends here. So I'm going to go ahead and draw it. There's my resultant vector. And that resultant vector is the vector sum of A plus B. And when you have vectors in unit vector form, they're very easy to deal with. It's as simple as this. You add components. So here we're going to add the plus 15 to the minus 10. I'll go ahead and write it out. 15 plus a negative 10. And that's going to give the x component of the resultant. Then the j component we get by adding j components. So we got minus 3 for this j component and minus 3 more. So we might write that something like minus 3 plus, I'm sorry, I said minus 3 more. I meant minus 7 more. How about plus a minus 7? J. Okay, so and now we just simplify. 15 minus 10, 5i plus, okay, negative 3 plus a negative 7 is negative 10. And then j. I don't really need these parentheses. We could write this a couple different ways. Let's see, 5i minus 10j is fine. Or we could write that 5i plus a minus 10. Whoops. Yeah, that's fine. Minus 10j if we want to put that in parentheses. Or we could write this 5i plus 10 in the minus j. I like to put the minus signs with the unit vectors because then each term is like magnitude, direction, magnitude, direction. So any of these ways are perfectly acceptable for calculating a resultant. Now, I want to keep this video short. The intention here is just how you add vectors in unit vector form. I've demonstrated that. If I wanted to, I could find the magnitude of the resultant because our resultant vector we know is 5 to the right and 10 down. I could draw a quick sketch. 5 to the right, 10 down. There's a sketch of our resultant, not to scale. I would find the resultant by Pythagorean theorem. Magnitude of r squared would equal 5 squared plus 10 squared. And the angle here would be the inverse tangent of 10 over 5. I'm not going to do that in the video. I just thought I'd at least chat about how to do it. Point of the video is how to add vectors in unit vector form. You do so by adding components, just like I did here and here. It's a pretty simple process. Hope this video helps. Have a great day.